Here is an important question from the chapter Magnetic Effects of Electric Current of class 10th. From examination point of view, it's a very important question, and this is an application of right hand thumb rule. So the question goes like this. The question says in the given figure, so you see some figure like A, B, some two cross and a dot. So in the given figure, point A and B, the A and B, those points represent two straight wires carrying equal amount of current. So if they carry equal amount of current, you must be knowing that the strength of magnetic field due to them will be of same magnitude. So the two straight wires carrying equal current in a direction normal means perpendicular to the plane of the paper inwards. Cross means inwards. Dot means the direction of current is outwards. So that is symbolic representation that you should know. So whenever on a paper cross is shown, its meaning is current direction is out to inward to the plane of the paper. Dot means current is inside the paper to outside, and that too perpendicular. Means what? Normal. So ultimate, what is the summary? It is told that at point A and B, that is a labeling, but this is the point. Okay, at point A and B, there are two straight current carrying conductors which contain equal amount of current, and current is flowing from outside to inside the plane of the paper. Okay, then we are told that first one, what will be the magnetic field at midpoint K? So K is at same distance. So I'm just showing R because field lines will be kind of concentric circles for a straight current carrying conductor, but R is not radius. R is the distance. So what is the magnetic field at midpoint, point K, of the line joining points A and B? So here, what is the magnetic field strength? That is what we are supposed to say. And whatever we say, we have to give a reason. So let's begin. So current at A is a straight current carrying conductor. So current is going from out to in. So we will apply right hand thumb rule. And when you apply right hand thumb rule, you can just point the thumb inside the paper and just see how your four fingers rotate. And when you do that, you will realize, however, magnetic field will be in form of concentric circles. That you know. Magnetic field will be in form of concentric circles around at that point where the conductor is, and field will be like this. Okay. Direction of magnetic field, please apply right hand thumb rule. So I have drawn that concentric circles. Right hand thumb rule. Just put the thumb at point X on the screen. Okay. And just turn the four fingers, you will know the direction of magnetic field. So I did that and I found that magnetic field is like this, clockwise. Direction of magnetic field is always clockwise when current is from top to bottom. When current is from bottom to top, it will be anti-clockwise when the conductors are placed in, like this, like this. So current top to bottom means field will be in anti-clockwise direction. So that is what I'm doing. So current is inward. So that is it. So let me redraw this. So that cross points are the location of that straight current carrying conductor which carries current from outside the paper to inside the paper. So because the straight current carrying conductor is straight, the field will be concentric circles. Okay. And when we apply right hand thumb rule, we realize that magnetic field is, that arrow shows magnetic field is in clockwise direction for the conductor at point A. For point B also, the magnetic field is in clockwise direction. See, clockwise, that is the field direction. Now I just make these arrows a bit dark so that you realize what exactly is happening. See, these are the lines, concentric magnetic field. So field direction you see. For the conductor at point A, the current is in clockwise direction. For the conductor at point B, the magnetic field is between the conductors in anti-clockwise, but overall it is clockwise. This is also clockwise magnetic field. Magnetic field direction is clockwise. For actually that B represents a magnetic field, but points A and B are the locations of the two straight current carrying conductors. So for both the conductors at point A and B, magnetic field is clockwise direction, due to which what happens, you see, for conductor at A, magnetic field is you see in this direction, and for B, current is in the opposite direction. So for one of them, current is like this, it's coming. Another is it is going. So when field are in opposite direction at point B, at point K, K is that dot. So field is in opposite direction, they cancel each other. So at point A, magnetic field strength is going to be 0. And that point will be under the influence of Earth's magnetic field, but not due to the magnetic field due to these current carrying conductors. So the first question I guess I answered. What will be the magnetic field at the midpoint? Midpoint means what? Field strength at point K will be same. Okay, so magnetic field strength is same, but their directions are opposite, so they are cancelling each other. So literally, I have to draw the diagram something like this. I'm just redrawing this so you understand what exactly. So magnetic field strength, you see, this is fine like this. That is called clockwise direction. When I redraw, you realize that what happens at point K. So for B, field direction is this is the opposite direction. So what happens at one point, the field will start traveling from A to B like this. So field goes like this and like this. So you know B is a direction, you see. B is field direction that I'm drawing here. And A's field direction I'm drawing near A. See, field went like this, like this, like this, like this. It goes around K, but it doesn't come near A. So for two straight current carrying conductors, if they are placed at some distance from each other, at the midpoint or between the conductors, the field strength will depend upon the direction of current. So current direction for A and B is top to bottom, means what? Out to in. For both of them, current is out to in. So because current direction is same, for both of them, magnetic field is in clockwise direction. As a result, field travels around the points A and B without touching the midpoint. So the field doesn't come at point K. So magnetic field at point K, this is point K, which I'm just darkening. So here magnetic field strength is 0. No magnetic field at that point. But if you still want to know what is magnetic field at point K, that point is under the Earth's magnetic field. So that is it. So this is the best diagram for the first question. What will be magnetic field at point K? 0. That is at the midpoint of that is it. And if the question, give reason, they say, no, give reason means you can draw the first diagram that I have drawn just to show that concentric circles, as they approach the point K, they are perfectly in opposite direction, field direction, opposite, so they cancel at K. And ultimately, if the examiner asks us to draw the magnetic lines of forces for such a situation, please draw like this. The field will just travel around points A and B and will never reach K. So magnetic field at the midpoint of these two straight current carrying conductors, in which current is in the same direction and that too out of the paper to inside, is 0. So I answered the first question. This is it. So here you see this picture tells magnetic field lines around the current carrying conductor is in form of concentric circles whose direction is given by right hand thumb rule. You have to draw like this, and here yeah, that they have shown here that current is from bottom to top. This picture shows bottom to top, but in both of them is same, no? So for one, it is anti-clockwise direction. For other, it is same direction. So both of them anti-clockwise direction. As a result, at coming to point K, the fields are in opposite direction. So magnetic field becomes 0. So the first question, you see, direction of magnetic field at K due to wire A is opposite to the magnetic field due to wire B. Since current is equal, magnetic field cancel each other. Net magnetic field will be only due to the magnetic field of the earth. So that is the first question, but I have drawn such a beautiful diagram. So the field runs like this, but in case you want to show current is like this, a bottom to top. The question was top to bottom, by the way. So here field runs around them. Sometimes they say, no, draw magnetic lines of forces. Then you are supposed to draw like this kind of a loop. So magnetic field will be like this, a loop, okay, that runs around those points A and B. That's the first bit. Let's answer the second bit. Second bit is, in what direction will magnetic needle of the compass rest if it is placed at point K? See, at K, magnetic field due to the straight current carrying conductors is nullified, 0. So all the magnetic field at point K is due to field of earth. So if we place a magnetic compass needle at point K, it will not be deflected by magnetic field of the wires. It will point along the magnetic field of the earth. That means the north-south direction. So at point K, if you place a magnetic compass needle, it will align itself along the earth's geographic north and south, which is actually magnetic south and north. That was the second question. Now let's see the third question. The third question is, what will be the effect of magnetic field at point K if current in wire B is reversed? That's a very beautiful thing I do here. See, say for example, at point A, current was a top to bottom, no? So this is the current direction. If this is the current direction, for a straight current carrying conductor, magnetic field will be in form of concentric circles. So I am applying a right hand thumb rule. Thumb is a downwards, and I am turning my 4 fingers, because you are not able to see me, but I am just applying. I am putting my thumb along the current carrying conductors with the thumb is a downward, and I am turning the 4 fingers. And I see that current is in clockwise, magnetic field is in clockwise direction. So I have shown magnetic field direction here. So it is clockwise. Magnetic field direction is clockwise for the conductor at point A. And then there is another conductor where current is not, because direction of current at point B is reversed. By the way, this B is magnetic field and that B is a point. So here direction of current reverse. So that's why at point A I kept cross and at point B I kept a dot, just to tell that current is from inside the paper to outside. So current is in opposite direction. But whatever magnetic field is in form of concentric circles, and we have to apply right hand thumb rule, and I am applying it. I place my thumb from bottom to top, and as I turn my 4 fingers, the magnetic field is in anti-clockwise direction. Magnetic field is in anti-clockwise direction. So that is the field direction. So here at point B, magnetic field direction is in anti-clockwise direction. Anti-clock direction. These are all 1 mark questions. If current is bottom to top, magnetic field is in anti-clockwise direction. If current is a top to bottom, magnetic field is in clockwise direction. The MCQ kind comes. Now you observe what happens. See, these are the magnetic lines. Okay. Field is like this. Magnetic field is in the same direction. So magnetic field is same direction means what? At point K, the field intensity will be maximum. So magnetic field strength will be maximum between the two straight current carrying conductors if direction of current in both of them is opposite. So magnetic field is strong. So it will be strong if the conductors are very close. In fact, if conductors are far away, then field will be mild. But why I'm saying magnetic field strength is maximum, it's because the field lines, direction, you see, direction of magnetic field is adding up at point K, adding up. So magnetic field strength due to the conductor at A and magnetic field strength due to the conductor at B, they are adding because direction of magnetic field is same. So in that way, at point K, field strength should be more. But the condition is also there that the distance between the conductors should be less. So that is the answer to the third one, C bit. So if current in wire B is reversed, magnetic field of both wires at K, point K, will point in same direction and add up. This is important. They add up. Like this, you have to write answer in the exam. Many of the times the cut short answers that small children write, they don't complete a sentence and they wonder that why we got less marks. Please mention like this. Magnetic field add up, draw the diagram, show that it is clockwise, anti-clockwise, the way I explained. You do that much and then you expect a full score for this 3 marks question. 3 bits means what 3 marks will be, but you should answer properly. Otherwise, you write cut short, they will provide you marks cut short. So that is it. So magnetic field at point A is no longer be 0. That means it is no more 0. But field will be more, but that depends upon how much more, how much less, depends upon other factors, that how much current is there in the conductors, whether they are closer or farther. So those all. So this is a very beautiful question. You watch it from the beginning, note it down the question as well as answer in the notebook so that before your exam you can do a very quick revision of this. These are very good questions and I'll try to be consistent in posting this kind of important questions from class 10th as well as 9th from maths and physics. I hope this video is useful. God bless.